Hello everyone, my name is Yunus Najif and I will present to you our capstone project of the subject controlling the robotic arm using OWI-535 along with my project's teammates Ahmed Osman, Khalid Walid and Abdullah Dalis. This video will explain briefly the whole project including variety of materials.
As we know that the science of robotics become more important in recent times, playing a crucial part in our daily life, starting from vacuuming floors to the industrial manufacturing of various products. The OWI robotic arm is considered as a trainer that teaches basic robotic sensing and locomotion principles. It has 5 rotational joints moved by small motors, which are the elbow, the wrist, gripper, shoulder, and the base. We have purchased our OWI kit from Images online store for scientific instruments.
The OWI kit comes along with a USB interface controller and a software CD. By using the USB interface controller and the graphical user interface, we analyzed the arm's movement and the USB protocol, which we found that it sends a single hexadecimal byte for each joint at a time, where the joints performs a time-based movements. Another way to demonstrate and analyze the arm's movement is through constructing a state switches control circuit. In this process, we have used 3 dual full bridge drivers, single line electric cables, single line doubled pins, and a digital analog training system.
The dual full bridge drivers provide electrical clockwise and anti-clockwise signals to enable direct and reverse movements of the motors. By following the instructions of the component's datasheet, we constructed the circuit and started controlling the arm manually through the switches. The main objective of this project was to make a program to give the arm a sequence of commands to operate automatically. After many experiments, we settled to accomplish this by programming a microcontroller chip using C as a programming language, compiling it to assembly language through micro-C, then programming the microcontroller using DIY loader device along with its software. After connecting the microcontroller to the 3 dual full bridge drivers and an LCD screen for output display, we maintained a sequence of commands to move the arm and pick up a maximum of 3 objects, then throwing them back in a small box placed behind the arm. We tried to perfect the movements as possible as we could. The arm has many manufacturing drawbacks that affected the joint's movement. Anyway, the task was accomplished.
Now comes the part of demonstrating the constructor circuit on a printed circuit board. For this process, we first needed to design the circuit using the PCB wizard. The next step is to print out the design circuit on a transparency. Due to the complexity of the design, we had to print it on a double-layered board using a board printer device. After printing the circuit on the board, it has to be placed in a prepared etching solution to obtain the final circuit. Now all what is left is drilling the board to place the components, soldering and testing the board.
You can refer back to our project's report for more details about the project. Thanks for your attention.